Hey everyone, so I've finally adjusted to the new lifestyle and I'm back again with another video, and in this one we'll be talking about trees and DOM traversals using JavaScript. If you're new over here, this is Vishal, and on this channel we talk about JavaScript and front-end development. So if you're interested in that kind of stuff, please consider subscribing to the channel. It gives me a lot of motivation to keep recording. So without wasting any further time, let's jump into the video. So let's get started by first looking at what I have so far. So eyes on the screen, and as you can see, I have already created a class called binary tree. This is actually a binary search tree, but I've just named it binary tree. So let's go with what I have so far. So this class is having a constructor which takes a sequence. So sequence is an array, and we basically convert that sequence into a tree. So the sequence that is passed to this constructor is a pre-ordered traversal of the tree. So the pre-order traversal, we will talk about it later in the video in detail, but just understand that in the pre-order traversal, the first item in the array is going to be the root of the tree, and that's what is going to happen in this code. So we are taking the node, the first element, when it is passed to the insert node, the root is going to be null. So we are just making the first item in the array to be the root node of the tree. Okay, now the node structure of a tree is pretty straightforward. We have a value assigned to that node, and it has left and right pointers, right? So coming back to our binary tree, the insert node is, I already told you, the first item in the sequence is going to be the root node, since it is a pre-order traversal. Then for the rest of the items, we have a condition over here. If the node.value is less than the root value, it moves to the left side of the tree. If it is greater than the root value, it moves to the right side of the tree. So that's the logic written over here. We are recursively calling the insert node, because once we go to the left side of the tree, we are now focusing on the left subtree of the parent tree, right? So we are just doing root.left, which means we are focusing on the left subtree. Okay, and the similar thing happens on the right hand side as well. So if when we are moving towards right, we are focused on only on the right hand side of the tree, so we don't really care about the rest of the tree. So that's why we pass root.right over here. So at the end of the insert node, we are just returning the root, which is assigned to the root of the tree. Okay, so this is a very basic snippet of converting a pre-order traversal into a tree. So we'll be using this to construct our basic tree, and then we will be writing the traversal stuff. All right, so let's look at the index.jsx. So I'm going to use my index.jsx for demonstrating a lot of these utilities. So the tree sequence that I'm using over here is 4213657. So this is nothing but the pre-order traversal of the tree. Okay, so 4213657 is going to give me a tree which looks like this. Let me zoom that a bit. Okay, so it is going to give me a tree with 4, since that's the first item in the sequence. That would be the root, and everything less than 4 moves to the left, everything more than 4 moves to the right. Okay, so now let's come towards traversals. So we have already created the tree. Now the agenda for this video was traversals, so let's come towards traversals. And there are two types of traversals. One is depth first traversal, and the other is the breadth first traversal. So the breadth first traversal is very straightforward. We move towards the breadth of the tree, which is first we go to the 4, then we go to 2, 6, then we go to 1, 3, 5, 7. So the sequence of visiting these nodes is going to be 4, 2, 6, 1, 3, 5, 7. That's the breadth first traversal. Let me clear this off. Okay, now talking about the depth first traversals. So in depth first traversal, there are 3 types of orders. One is in order, pre-order, and post-order. Another important thing to remember over here is that the breadth first order is going to use a queue, while the depth first order is always going to use a stack. Okay, keep that in mind. We'll be using this information while writing the code. Now depth first traversal has three types of orders, that is in order, pre-order and post-order. So before we write any code, let's just first understand how you can quickly tell what would be the in order, pre-order and post-order of this particular tree diagram that we're seeing over here. So it's very simple. Let's start with in order first. So for getting what in order is, just draw a line at the bottom of the tree and drop these nodes to the line. So that would be 1, 2, 3, then 4, then 5, then 6, and then 7. Okay, so the in order traversal for this particular tree is going to be 1, 2, 3, 4, 5, 6, 7. Okay, so that's the very easy way of telling what would be the in order traversal. Okay, now coming to the pre-order traversal. So pre-order traversal is nothing but what you are essentially saying is you're going to the depth of the tree, but when you visit a node, you basically log that node and then you go to the depth instead of going to the depth and then logging. Okay, so understand the terms over here. So pre-order is basically saying that as soon as I visit the node, I'm gonna log it and then move to the depth. Okay, so to quickly tell what the pre-order traversal would look like, you basically grab a pen and just draw from here. The order would be 4, 2, 1, 3, then 6, 5, 7, and you complete the loop over here. So the order of the pre-order for this particular tree is going to be 4, 2, 1, 3, 6, 5, 7. So 4, 2, 1, 3, 6, 5, 7. Let's tally it with what we have over here. 4, 2, 1, 3, 6, 5, 7. So that's the pre-order traversal, right? So you just draw this loop and you understand what the pre-order traversal would look like. Now the post-order traversal is similar to pre-order traversal. It's just that instead of traveling towards the left of the tree, we'll be traveling towards the right of the tree, and then we will reverse the sequence in which we visit each of these nodes. So let's draw the loop first. So the travel sequence from right would be 4, 6, 7, 5, 2, 3, 1, and we complete the loop. So the sequence in which we visited was 4, then 6, then 7, 5, 2, 3, 1. Right, so this is the sequence in which we visited the nodes when we started moving towards the right. Now to get the post-order traversal, you just reverse the sequence, and the post-order traversal would be 1, 3, 2, 5, 7, 6, 4. So now the theory part is done, so let's jump into the code. So we will go back to our binary tree.js. So don't worry about the React code over here, it's all presentational kind of things. So I'm not really talking about how and what I'm doing over here. I'm just telling you that I'm gonna use the tree sequence that is over here and use our binary tree class to generate the tree. And now we will be writing some functions to traverse through the tree and give me the in order, pre-order, post-order, and BFS order of traversals. Okay, so let's go to our binary tree again. Since this is a class, I'm going to add a few functions over here. Those would be, let's say, traverse. Let's start with in order. Okay, so traverse in order. Now the in order traversal is actually a depth first traversal, right? So I've already told you the depth first traversals use stack, and the breadth first traversals will be using queue. Now for this particular use case, I'm going to use call stack or call stack as stack by writing a recursive solution. But if you're interested in knowing about the iterative solution, do let me know in the comments. I'll make a separate video for that. But for the essence of time, let's just go ahead with the recursive solution in this one, and notice how we are going to write this traverse in order function. Now, recursive solution for traverse in order is pretty straightforward. You go to the left, root, and then to the right? So we're just going to do if this dot root dot left, then we basically say traverse in order of this dot root dot left. Okay. And here, okay, let's do one thing. Let's instead of returning from here or trying to make a sequence over here, we will make this function a generator, and we will yield the nodes that we travel to. Okay, so now this is a generator, so now we can do yield of this dot root. Okay, and once we have travel the route, now it's time to go to the right. So we go this dot root dot right, then we do this dot traverse in order, this dot root dot right. Okay, so this is going to give me the in order traversal. So the reason why we are writing it as a generator is because it's going to make things easier for me to traverse through the node in a for loop. Okay, we will see that as well, but before that I want to fix a few things over here. So traverse in order is not taking any parameters, but in my recursive call I'm passing a parameter, so this would need a root. Now since we are passing the root over here, we will not depend on this dot root, we will depend on our variable over here, or the parameter over here. Okay, so yield root, then root dot right, traverse, then root dot right again. Okay, so now this is going to work. So let's go back to our index.js, and here I have calculate traversals. So there is a helper function that I've written over here. So all I'm gonna do is do this. Okay, so let node of tree dot traverse in order, and I'll have to pass the root as well. So the way I'm gonna pass root is tree dot root, and it should print the result for me. So we can see that in order is now printing the result of 1 2 3 4 5 6 7. But something's weird about this, right? I don't really like this way of writing the code where I already have access to the tree, and using that I'm calling the traverse in order, but then again I need to pass the tree dot root over here. This seems a little odd way of writing the code. So let's fix this once. So we will go back to our binary tree, and instead of doing this, I'm going to create a function inside this function, which would be traverse. Okay, and we will move this entire thing inside this, and root will be here, and the traverse in order function will now invoke this traverse function. Okay, so that would be yield star of traverse, and now this particular function already has access to the root node, right? So we'll just do this dot root. Okay, so now doing this, now okay, we need to update these as well. So that would be traverse this, and then we go traverse of this. Okay, and since traverse is actually a generator function, so we need to add the yield star over here as well. Okay, so I think this should work. So what we have done over here is we have created an inner traverse function so that I don't have to pass the root node specifically, since we are already calling the traverse in order function as tree.traverse in order, so it already has access to the tree. Then why do we have to pass the root specifically? So that's why I wrote it in this way, so that the inner function is now responsible for doing all the recursive stuff, and the outer function is just going to yield the values. Okay, now let's try it out. So I'll go back to my terminal, build this. So once this is built, my React app is refreshed. We go back to our browser and you can see that the in order traversal is still going to give me 1 2 3 4 5 6 7. But one thing that we forgot to change is we go to our helpers and we don't need to pass root node anymore. So even if I remove the root node, it is still going to work fine. 1 2 3 4 5 6 7. So that's in order. Now if you are interested in the iterative solution, do let me know. I can discuss those as well, but in essence of time, I'll probably just skip the iterative approach and we will go ahead with the recursive approaches. Okay, so next for us is traverse pre-order. Okay, now we will keep everything same. The only thing that changes in pre-order is as soon as we visit the node, we yield it and then we move towards the depths. Okay, so this is all we need to do to have our pre-order working. So let's build our code again. Now that it's built, we need to update our helper to remove these comments. So now since I've one more thing to notice over here, since I've written traverse in order as a generator, now I'll be able to use my for of loop. Okay, so I don't need to do generator.next again and again. So for of loop will take care of doing the next, yielding me the next sequence, next element in the generator. Okay, so the same thing. So we have traverse in order, traverse pre-order. Let's uncomment this as well. Let's see. Okay, so this is giving me an error, so everything is fine. I'm yet to write this, so let's remove and let's see if my pre-order is working fine. So based on the diagram, if you remember, the sequence is 4 2 1 3 then 6 5 7, right? So this is exactly what we are seeing over here, 4 2 1 3 6 5 7. All right, so head back to our binary tree again. Now we will do traverse post order. So we are here, we will change pre to post, and in post order we first go to the depth and then we start yielding. So we first go to the depth and then we start yielding. So this is what would be the post order. So let's build our script again, and once that's done, we will head to helpers, we will uncomment this. Okay, so now post order is getting resolved because we have added the function, and here is the post order. So we have already discussed in earlier half how you can verify this. So you travel from the right and then reverse the sequence, which is 1 3 2 5 7 6 and then 4. Okay, so the post order is also working fine. Now the last one for us is going to be the BFS. So far we have seen all the depth first traversals, but we have not seen the breadth first traversals. So let's go here and write star traverse BFS, okay, which is going breadth first. Now for traverse BFS, we cannot use the recursive approach, right? Because BFS uses a queue. So far for the depth first traversals, we were using recursive approaches, because we would by using recursion we would convert our call stack into a stack and use that call stack as a stack and traverse through the tree, right? But for BFS we need a queue, so we cannot use recursive solution over here. So we will be creating our queue like this. Const queue is equal to the first item or first node in the tree that the BFS traversal will visit is the root node. So we will put the root node into the queue, and then our condition would be while queue is while queue is not empty, we will proceed and we will dequeue the current node. Okay, so the current node we need to dequeue that so that we can yield that value outside and make the queue empty again. Okay, so the current node we have to dequeue that, so that would be queue dot shift. So we have dequeued the current node and we will yield the current node. Okay, now what happens with the rest? So the queue now has to proceed to the next level, right? So we are already on the current node. Now we need to see whether the left and right are present, and we have to push those to the queue. So it's very simple. We will write if current node dot left, then queue dot push the current node dot left. Okay, and the same thing for the right hand side as well. Current node dot right, current node dot right. Okay, so I hope this makes sense. So what we are trying to do is we are using the queue as a reference for traversing through the tree on the breadth levels. So the first item in the tree that would be traversed via the BFS approach is going to be the root. So once the root is added to the queue, then it is dequeued and yielded out. Now what happens with the next two? Now to reach the next level, we just use current node, whatever we dequeued, and just see whether the left is present. Then we push that to the queue. If the right is present, we push that as well into the queue. And when the loop reiterates, now the queue is again not empty, and the first item in the queue would be the item on the left, and the same pattern goes on until the queue is empty. Okay, so now the traverse BFS function is written. Let's test it out. So I'll just build my utility and then head towards the helpers and remove my for loop again. Okay, so tree.traverse BFS. So I'm just going to push into the BFS order and let's see if it is working fine or not. So according to the BFS, the sequence should be 4 2 6 1 3 5 7, which is 4 2 6 1 3 5 7. All right, so this basically covers the basics of all the traversals. Okay, so using JavaScript we created a tree first, then we wrote the logic to traverse through the entire tree in different orders, right? So now remember the video is about DOM traversals. So far we have not done any kind of DOM traversal. We have just done a proper tree traversals, right? So now the idea behind talking about trees first is because DOM is also a tree. It's just that a node in a DOM tree can have multiple children compared to what we have over here. So now let's write the pre-order traversal for logic for traversing a DOM tree. Okay, so I've created a file called utils.js, and I've already created a function definition over here, which is traverse pre-order. Okay, now the DOM tree, we will have to pass the node over here, which can be document.body or any other node in the DOM tree. Okay, so if there is no root, the first things first, we need to return from right here. Okay, now pre-order traversal, as we saw earlier, as soon as you visit the node, you yield that node. So we have visited the root, so we are going to yield the root. Okay, now we know that a dorm tree can have n number of children. So we need to loop over all of these children and then recursively call our traverse pre-order function for each of the child nodes, and that is all we need to do to traverse pre-order on a dorm tree. So let's do for let child of root dot children. Okay, so on browser, if you do document.children or document.body.children, it is going to give you all the child nodes of document.body. So we are playing on the same thing. We know that root is a DOM node, and we are doing DOM node.children over here. So everything is fine over here, and I told you that we have to recursively call our traverse pre-order for each of these child nodes. So we will do yield star traverse pre-order, and we will pass our child over here. Okay, so that's basically the traverse pre-order for a DOM tree. So I'll not be demonstrating the execution of this particular function because let's save that as a part of our next video, where we will be writing polyfills using this particular function, and that's where we will see the execution of this. So I do not want to make this video very long so that it gets too hard to watch everything at once, right? So we will divide this into two parts. So that's all for this one, guys. If you have any questions, let me know in the comment section. I've missed you a lot. For months I was away, but now I'm back and we are going to learn more together. So subscribe to my channel and hit the notification bell to get notified about my next video. So see you in the next one. Bye.